Hi, and welcome to Group14's project on conceptual architecture of Void AI. Our report begins with an abstract which looks at Void, an open source AI-powered IDE based on Visual Studio Code, which we use to develop our project website. Void extends VS Code's modular design by integrating privacy-focused AI through secure adapters that connect to local or external language models. Using the same layered principles, we created a simple, structured website that has clear separation between interface, logic, and content, which mirrors Void's renderer, main, and extension host layers. This approach demonstrates how modularity enhances scalability and maintainability even in the smaller projects. Our findings show that Void's architecture supports strong extensibility and AI-assisted editing, though some performance trade-offs do exist due to its Electron foundation. We worked with GPT-5 to help us organize and structure a report while ensuring there was human oversight. Overall, the project highlights how thoughtful architecture design and responsible AI integration can improve both the software development and our team collaboration. The introduction provides background on Void and the context of our project. Visual Studio Code was designed as a fast, flexible, and extensible editor which Void builds upon, as I mentioned, by adding AI-powered features while prioritizing user privacy and community-driven collaboration. For our project, we used Void to develop a modular website. The site was intentionally structured with self-contained sections mirroring Void's layered approach to separate interface, logic, and system operations. This demonstrates how IDE principles like maintainability, scalability, and separations of concerns can guide practical web design. The report is organized to make these concepts clear. It starts with an architecture overview, followed by external interfaces, use cases, the data dictionary, naming conventions, key findings, lessons learned, and AI collaboration. Each section illustrates the website structure and workflows while connecting the design decisions back to the principles of Void's architecture.
Here we have the conceptual architecture for Void. At the very top, you have the workbench, which acts as the main user interface. It manages the editor tabs, chat panel, menus, and sidebars, and it routes all user actions to the appropriate services below. Beneath, you have the configuration system, which manages the editor's settings, layout, and opens files. You can think of it as the layer that keeps the interface state synchronized with the internal logic. In the center, there you have the text editor. It's the core workspace where code is displayed, like where you're modifying or editing it, and it maintains an in-memory buffer that supports typing, and all other real-time editing actions. To the right side, you have the file system controller, which that handles all file operations specifically when a user opens, saves a file, or when the request travels through the configuration subsystem to the file system. That communicates with the operating system through IPC. On the left side, you have the AI subsystems. This extends the basic workflow of VS Code, and this is the main thing that makes Void Void. You have the code edit service, which listens for AI-driven actions like /edit, collects the relevant code context from the text editor, and forwards it to the LLM message server. That service prepares a structured prompt and sends it to the tool manager, which then chooses a model, and the provider adapter connects to that model and returns a structured response.
Void follows a layered architecture style, which organizes the system into distinct layers that separate interface, logic, and system operations. This structure makes the platform easier to upgrade and control, which is especially important since Void integrates AI tools while protecting user privacy. The layers also keep the design simple and understandable for open source contributors so developers can modify or extend the system without breaking other parts. Alongside this, Void also uses implicit invocation, especially in its extension system. This means that extensions like new languages, commands, or AI features can plug in and respond automatically when certain events occur, without directly changing the main program. This design balances flexibility and performance, letting developers safely expand the system while maintaining stability. Void is made up of multiple subsystems that each handle a key part of the editor. The Workbench UI manages the windows, the panels, capturing the user input and passing it to the other subsystems. The core services runs in the background, taking care of launching, updates, and resource management. The text editor is where the code is written and edited, connected to autocomplete and the chat edit service so that AI can assist directly in the editor. The terminal lets users run and test the code without leaving the app, while the version control supports Git and GitHub for collaboration. Other subsystems like extensions, configuration, and the file system manager handle customization, setting, and file access. On the AI side, services such as Code Edit Service, LLM Message Service, and provider adapters coordinate communication with large language models. Together, these subsystems create flexible, modular environment that combines standard coding tools with intelligent AI assistance.
Here is use case 1. It's a classic dev loop. Most of the architecture here in this use case is inherited from the VS Code architecture. First, the user opens a file, and the workbench sends the request to the configuration subsystem, which forwards it to the file system controller. The controller reads from the disk and streams the context back over IPC. The text editor loads the buffer and renders it through the workbench. Next, the user edits, or make any changes it wants in the text edit buffer. It can undo, redo, and it all will stay local. Next, when the user is happy with the work, they'll save. This is triggered by the workbench, and the text editor hands the current buffer to the configuration subsystem, which calls the file system controller to write back to the disk on success. Status then updates to propagate the workbench so the UI shows the saved state. Here is the second use case. This one is more of the void side of the code, where the user actually uses the AI/edit command. The workbench captures the request, or the /edit in the side panel, and sends it along with the selection and file context to the code edit service. That service queries the text editor for surrounding code to build a complete context window. The LLM message service then turns the goal and context into a provider-specific prompt. The tool manager picks a model based off user settings or policy, and then the provider adapter sends the request to the selected LLM and streams tokens back. As suggestions arrive, they flow to the text editor as a proposed diff. The workbench shows inline diff zones so the user can preview the changes. If the user accepts, the text editor applies the patch to the buffer and triggers the normal save path through file system controller. If the user cancels, the buffer is unchanged and the suggestion is then discarded.
Void's external interfaces define how users and systems interact with the editor. Most of the interfaces come from VS Code's Electron shell, like the sidebar, the menu bar, and the text editor, but Void adds a unique one where AI features are built in. This panel offers quick code suggestions, inline edits, and checkpoints so the users can review or undo AI changes. Void also extends VS Code's API system, supporting custom and even LLMs for privacy and flexibility. And like VS Code, it connects system services such as file system, terminal, and clipboard through Electron. Overall, these interfaces create a smooth link between user, system, and AI while keeping control in the developer's hands.
Working on this project taught us a lot about software architecture, of course, but also teamwork. We faced one major challenge when a group member dropped the course late in the term, right before the first assignment is due. This forced us to quickly reassign tasks, and that experience showed us how critical good organization and communication is in a team project on a time crunch like this. We also learned the importance of diagrams. They made it much easier to understand how Void extends VS Code's architecture, and it was pretty tricky to separate the inherited parts from what Void added, but the process gave us a much better understanding. Next is our conclusions, which are similar, but to wrap it up, Void's architecture builds on Visual Studio Code's layered structure, but evolves it with AI integration. The renderer handles UI, the core manages logic, and the main process connects everything to the system and AI providers. The use of implicit invocation makes Void highly responsive and adaptable, perfect for streaming AI responses in real-time editing, which is very useful. It's modular, privacy-focused, and also designed for extensibility. Finally, we have the AI collaboration. For this project, we have the AI teammate, which we use ChatGPT version 5. We used it mainly for planning and organization, not as really a content general, though it did help with some research. We included the official project guidelines and our team's outline and prompts, and the AI created a detailed report structure with section summaries, like what it wanted in it, and estimated lengths to help us figure out how long each section should be. This helped us plan early, stay consistent, and made just our lives moving on a lot easier. Thanks for watching our presentation. Here's our last slide with our references.